I want to show you the quadratic formula, and not only the quadratic formula, I'm going to show you something called the discriminant, which comes from the quadratic formula. And the quadratic formula can solve 100% of all quadratic equations, which is pretty neat, because that kind of thing's a rarity in mathematics. Alright, so first of all, a quadratic equation has to look like this. ax squared plus bx plus c equals 0, and the defining characteristic of a quadratic equation is that degree 2 exponent there, an x squared in there, okay? So if you have a quadratic equation, then your solutions are going to look like this. Negative b plus or minus the square root of something I'm going to call capital D all over 2a. Now, if you've seen the quadratic formula, you know it doesn't look like that normally, but I'm calling this capital D thing b squared minus 4ac. And so if you've probably seen the quadratic formula in a textbook, it looks something more like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And depending on your high school teacher, you may have learned a way to sing this to memorize it, and I'm not going to do that. But there it is. And if you notice here, what I have under the square root is exactly this thing I call the discriminant. So why am I pointing that out? The discriminant can tell us a few things, okay? So first of all, if the discriminant is 0, then I know my equation has two real roots. And when I say two real roots, I mean that they are different and they are real numbers. Okay, if d is 0 itself, then I have one real root. Okay, and what actually is happening is you have the same root show up twice. Alright, now I know these are not good sentences, but I think it makes the point. Now, lastly, if d is less than 0, then we have two let's say complex roots. So now I get some i's involved. Okay, so depending on your textbook, it may say no solutions. That's because you're not dealing with complex numbers. Alright, so I'm going to show you 3 examples of quadratic equations, and they'll follow these 3 cases with the discriminant, and I want to highlight the discriminant first, and then we'll figure out our solutions. Okay, so for question A here, we have 4x squared minus 4x minus 27 equals 3. So to start this, remember I need to have 0 on one side, so I'm going to subtract the 3 over and end up with a negative 30. And then I think it'd be smart, I could apply the quadratic formula immediately, but I think it'd be smart if I took out a 2, just to make my arithmetic smaller, so I don't have to deal with such large numbers. And if you notice, if I divide both sides by 2 here, 0 divided by 2 is still 0. So I can start with this equation, 2x squared minus 7x minus 15. Now first I want to look at d. Remember, d was the discriminant, which is b squared minus 4ac, which in this case would be negative 7 squared minus 4 times 2 times negative 15. And if you do that work, that's going to be 49 plus 120. I get 169, which is positive. Since it's positive, I know that my solutions are going to end up with 2 real solutions. Alright, so my solutions now, coming down, are x equals negative b, which would be a positive 7, plus or minus the square root of my discriminant, which is 169, all over 2a, and a was 2, so I have 2 times 2, which is going to be 4. And what's nice about this is if you remember, the square root of 169 is actually 13. So I have 7 plus or minus 13 over 4, which means I have x equals 7 plus 13 over 4, which would be 20 over 4, which is 5. And I have x is 7 minus 13 over 4, which would give me a, negative 6 over 4, which reduces to negative 3 halves. So my solutions here are negative 3 halves and 5. There's my first set of solutions. Alright, now for part B, I see this a lot where people will say, okay, w equals negative 1, or w plus 2 equals negative 1, and that is heresy. That's witchcraft. That does not work. It only works if we have 0 on one side. So I need to distribute the w first. I get w squared plus 2w plus 1 equals 0. Okay, now if you're good with factoring, you can see immediately this thing's going to factor, but just work with me here. Okay, so let's look at the discriminant first. So the discriminant is b squared, which in this case is going to be 2 squared minus 4 times a times c. And if you notice, that's going to be 4 minus 4, which is 0. So if you remember what we said, in the first example, d was positive. We had 2 roots. The second was d is 0, so we're going to have one distinct root. Alright, so let's look at it. We get x equals negative b, which is going to be negative 2, plus or minus the square root of my discriminant, which is 0, all over 2a, which would be 2. So that ends up with negative 2 plus or minus 0 over 2. I end up with x equals negative 1 as a solution. That's not too bad, right? Okay, now this third one, part C, we have 4x squared minus 3x plus 1. And this is not an equation at all, is it? To make it an equation, we're just going to add equals 0 here. Okay, so first of all, we're going to look at our discriminant here. And remember, the discriminant is b squared, so it's going to be negative 3 squared minus 4 times a times c. Okay, so that's going to end up with 9 minus 16, which is a negative 7. Negative 7 is less than 0. So what does that tell me here? Depending on your textbook, we're going to either have no solution or we're going to have complex roots. Okay, so let's proceed with a quadratic equation then. So here I have x equals negative b, which would be 3, plus or minus the square root of my discriminant, which is the negative 7, all over 2a, which would be 8. Alright, so here I end up with then x equals 3 plus or minus, there's not really much I can do with square root of negative 7 except I can take out the imaginary unit, I, all over 8. And there it is. Now, if your textbook doesn't deal with complex numbers at all, then you'd probably say no solutions or no real solutions. But if your textbook does deal with imaginaries and complex numbers, then here it is. And you take out the imaginary unit. Okay, so this is 3 examples of the quadratic formula, and it shows the 3 different cases. I like to put in the discriminant here just because, well, in one way it makes your arithmetic a little easier. In another way, it highlights exactly what kind of expectation you should have from your outcomes. Either way, I hope this makes sense. And if you have any questions, please let me know. I'd be glad to help. I want you guys to understand math. It's a beautiful subject. If you need any help, let me know. And thank you for watching.